Okay, we're going to investigate some super athletic prowess. Let's take a look here. Take off, we're accelerating, positive acceleration, negative acceleration, slowing down, coming to a rest, negative constant velocity, looks like we're moving along, and then boom, come to rest. This is amazing athleticism. We compare it with some other athletes, some other runners. So notice what this allows us to do. Because we have delineated the course in meters, I can look at my exact displacement and know where I am. Say, so here I'm right over the 4-meter line. Okay, and what time is that? I'm over it at 2 seconds. However, that is not very precise. Now, if we use QuickTime Player, we can get a much more precise time by going to the frame number, because there are many frames in a second. And so we see right now I am at frame 86. So if I go to Excel, I can put down, yes, I'm at 4 meters at frame 86. I said 86.5 when I measured this. And so now I have the frame number versus where I am at any given time. Now how do I turn that into seconds? We need to correlate frame number with time. And so I can go to, for instance, let's go back to time, and I can go up to the very end. This is the last frame that was 12 seconds. This would correspond to exactly 13 seconds, and the frame number is 390. So then I can say, oh yeah, there are 390 frames, and that corresponded to 13 seconds. So what is that? How many frames, I just need to divide that, is equal to, I put an equal sign, so Excel knows to do a program, is this cell, K1, divided by this cell. And there are 30 frames per second. So now I can log my distance per time in seconds rather than frames. All I have to do is say equals this frame number divided by the number of frames per second. And I find that at 1.3 seconds is when I'm just beginning at minus 0.5 meters, because I started a little bit behind the starting line. And then I can just copy all these. I can do a cut and paste, or a copy and paste, or I can just drag this down. And you see there's a problem. Why is this a problem? Well, the best way to find is to double click on it and see that, you know, what we hoped was it would divide each one of these by 30. But what happened is it divided this one by the one below 30. Because as I move down, it just takes the next one down. Or this one, instead of 102 divided by 30, is 102 divided by this guy. So there's a way to fix that. You just go here, and if you don't want this 4 to change, you put a $sign there. And it won't change it, it'll keep it there. So now when I drop it down all the way to the bottom, I've got my time in seconds. It takes each one of these and divides it by that number. So now I'm very happy. And I could go check. I could go check and say, you know, am I at 11 meters at about 4 seconds? I can just go back, I can go back to seconds and say at 4 seconds I'm at about 11 meters because this is 10. Nice. So now I can graph my displacement as a function of time. I just take these two guys, I go to my scatter graph under charts, and I make a scatter plot. Ah, lovely. So what you see here is time in seconds. And here I have displacement in meters. And you can see at the beginning I'm not moving. So as time elapses, I don't change my position. But here you can see I'm moving along pretty quick. As time progresses, I go forward. I come to my furthest point, about 15.5 meters, stop here. I can tell I'm stopped because the slope is 0. There's no change in displacement with respect to time. And then I change directions. I have a near constant negative velocity. And I can see that here because the slope is constant. So I have a constant negative velocity, and I come to a rest at the end, shown by this being flat. So how about velocity? Let's graph velocity. Let's find the slope of this line. So velocity in meters per second. So the velocity is a change in displacement over time. So this is going to equal this displacement minus this one, divided by the time it took. Oh, right, that's just a difference in time, which is this time minus this time. And there you go. Now I see at this time, at 2 seconds, I was moving at 2.7 meters per second. And all I need to do is just drag this down. And I've got my, oh, look at this, a negative velocity when I'm moving backwards. Great. And I can copy this and paste it up here. Okay, so I have a problem here because the value is undefined. Why? Oh, because this is trying to take the difference of these two times and these two displacements, and this isn't a displacement at all. So I'll just say, look, in the beginning, I know I'm not moving, so we put 0 there. So the other question is, at what time am I moving this speed at 5.4 meters per second? Well, it's this difference in displacement and this difference in time. So I'm moving at that speed somewhere in between these two times because I'm speeding up. I'm speeding up from 4.6 to 5.4 to 6. So the correct time when I'm moving this speed would actually be the average of these two. And I can do that. I can just say, look, what's the average of these two? It's just 0.5 times this plus this. And so now I have my average time. Let's call this the speed time. And we can drop that down here. Do a cut and paste. And again, let's just give this, 1 second to it. 1.3, how about 1.3 seconds is when I agree I started. Excellent. Now, we can graph velocity versus time the same way. And see, look at my velocity now. Now I can compare my velocity and compare my velocity with my displacement. Let's make them so they're about right. So we see the 12 seconds lines up with the 12 seconds here. So these are about lined up. And let's take a look here now. Like here I reach my maximum speed of about 6.5 meters per second. Amazing. And this corresponds to where the slope of the line is highest. Here it flattens, it starts to flatten off, my speed decreases, and you can see the velocity dropping, right? And I pass through 0 right here. So here's where I'm standing still, changing directions, and you see that here because it's flat. Now here I have a constant negative velocity of about minus 2.5 meters per second. Great. And you see this straight line with a constant slope. And I come to a rest at the end as this flattens out. So how about acceleration? Acceleration is the rate of change of velocity. So that's going to be this velocity minus this one. I've got my change in velocity here. And I need to divide by the change in time. So here's when I'm moving at 3 meters per second minus how fast I'm moving here. And so my acceleration, oh, that's in meters per second, because I divide by time. And so this is meters per second squared. Great. And again, I can copy this to all these cells. And if I want, I can say, I wasn't accelerating at the beginning, I was at rest, and I'm good. So how about time? When is my acceleration 2.14? Well, again, I took the change in velocity over this period. So it would be the average of these two times. So how can I take the average of these two times and put them here? I don't have to. I've already done that. Remember this? All I need to do is cut and paste right here. Let's see if I did it right. Yeah, it took the average of these two times and put them here. So I can just take this, plant it there, run it down the column. and say that in the beginning it was, what, 1.3. Now I can, oh, and this is the acceleration time in seconds. So now I can find my acceleration as a function of time. Graph it here. Now you see it's kind of noisy because as the slope of this line changes just a little bit, the acceleration changes. But let's take a look. So let's take a look now, lining up the 12 seconds and the 0 seconds. We can see that, yeah, here my velocity is increasing. I have this constant positive acceleration of about 5 meters per second squared, about half of gravity. And then I'm moving at my highest velocity here, which we see is when this slope is the greatest. But I'm slowing down. So we see I have a negative acceleration here, now a negative maybe 3 meters per second squared. This is a very interesting place where I have a constant negative velocity, and we can see that two ways. One, this slope is constant. My rate of change of displacement is constant. And my acceleration, which is the slope of velocity, my acceleration is 0. At the end, I come to rest, so I have to slow down, so I have this positive acceleration. Right, because I was moving backwards, so I need a positive acceleration to bring me to rest. Okay, so if we want to find out, another way to look at it is the displacement, the change in displacement is the area under this graph. So you can look, this is when I'm moving the fastest, that's right here. But I keep moving forward even though I'm slowing down. We take the full area of this triangle, should be the total displacement, the change in displacement from here to here. And we can check that. So this triangle goes from about 1.5 seconds to about 5.5 seconds. So it's about 4 seconds wide, and its height is about 6 meters per second. So 4 seconds times 6 meters per second is 24 meters. But it's a triangle, so it's 1/2 base times height, so it's not 24 meters, but about 12. And you could see my change in displacement is roughly, okay, 15, but close to 12. So let's go back to my athletic prowess, my 6 meters per second. I'm very proud of that. But we remember that other athlete, who's a little bit faster than me, Usain Bolt, winning the 100-meter dash at 2009 with a time of, look at the time, of 9.58 seconds. So I'm curious about Usain Bolt. I can look him up on Wikipedia and see that, lightning bolt, and see that this was his fastest time, 9.58 seconds in 2009. So how does he compare to me? Distance, 100 meters, time, 9.58 seconds, and speed equals distance divided by time. What we find is, why didn't this work? It's because I put those letters in there. So we would really need to do this, distance in meters, and then I can take the meters out. And time in seconds. And now I can take the seconds out. Because Excel doesn't know how to read units. So the speed is in meters per second. And so we can see Usain Bolt had an average speed of 10.4 meters per second, slightly better than me at maximum speed of 6 meters per second, but I'm working on it. And consequently, this is not his top speed because he started at 0. So his top speed was likely around 11 meters per second, about 25 miles an hour. So, you know, the guy's pretty good.